which is on multi-step equations and inequalities, by looking at section 3.1, solving two-step equations. Now, two steps means two transformations. Now, transformations, remember from the last chapter, means you'd be adding the same number to both sides, subtracting the same number from both sides, multiplying both sides by the same non-zero number, or dividing both sides by the same non-zero number. So we're going to take two steps to do this. Now, before we actually start solving and showing the work, let's look at an example of a two-step equation and a possible solution. And I have it written right here. It says, tell whether the given value of the variable is the solution to this equation. This is the equation, the value for the variable. Notice that on the right side, your variable x is being multiplied by 2, and there's a 7 that's being added to it. That's where it gets the two steps. You've got to undo both parts. You've got to get rid of the 2 and the 7. But in this particular problem, to tell whether or not it is a solution, I'm just going to substitute right in. 1 equals 2 times negative 4 plus 7. 2 times negative 4 is negative 8. Negative 8 plus positive 7 is negative 1. So the answer is no. It's not a solution. You remember, a solution, you have to have a true statement. You substitute it in for the variable, you get a true statement. Now, we're going to go about and solve some two-step equations. So we'll start with the easy ones, work our way to the tougher ones. And there are some tougher ones here, so stay with me and make sure that you take notes on this and you write these examples down. All right, solving here. I have n divided by 4 minus 8 is equal to 1. My variable is n, it's being divided by 4, and there's an 8 that's being subtracted from it. Now look back here. We undo the addition or subtraction step first. We undo the multiplication and division step second. The reason that we're doing that is because we're undoing the statement. The order of operations says you multiply or divide before you add or subtract. Since we're undoing this, we reverse the order of operations. We undo the adding, subtracting, then the multiplying and dividing. So I'm going to get rid of the minus 8 first before I get rid of the 4 that's dividing into n. So I'm going to write this the more traditional way. I'm going to add 8 to both sides. Now the minus 8 and the plus 8 are going to cancel, but I don't have just n, I have n over 4. N divided by 4. And on the right side I have 9. Now it becomes a one-step equation, because now it looks like a problem that we had in the previous chapter where my variable is being divided by 4. I do the inverse, which is to multiply by 4. So 4 times the left side and 4 times the right side. Cross cancels out, that's 1n or n, and on the right side 4 times 9 is 36. Now you can check your answers. Plug the 36 back in for the variable here. I'm going to do it just kind of using a little mental math. 36 divided by 4 is 9. 9 minus 8 is 1. That looks like it's a good answer. I'm going to solve the other equations in similar manner, undoing the adding, subtracting, then the multiplying, dividing. So my variable is x, it's being multiplied by 8, and there's a 7 that's being added to that. So I'll get rid of the plus 7 first. I get rid of the adding first. I'm going to subtract 7. I'm going to use a little shortcut here. Those cancel out. I get 8x is equal to 47 minus 7 is 40. Now I'm one step away. My variable is being multiplied by 8. I do the inverse of multiplying by 8. I divide by 8, both sides. Divide the left by 8, you got to divide the right by 8. Those are going to cancel out as a factor of 1. I get x equals, looks like 5. So far these have come out nice and neat and positive and even. They don't always work that way, but as I mentioned, we're going to start out with the simpler ones. Now, C, my variable x is being divided by 2, and there's a 5 being subtracted from that. And that equals 3. So I want to undo the 2 and the 5, but I'm going to get rid of the 5 first because I undo the subtraction before I undo the division. So I'm going to add 5 to both sides. Again, I'm using the shortcut this time. And I have x over 2 is equal to 8. Now my variable is being divided by 2. The inverse would be to multiply by 2, both sides. And isn't that nice? X is equal to, looks like 16, and that's my answer. Okay, now we're going to look at more equations here. And these equations are a little different than the other ones because these equations have a variable expression, that part's the same, but there's a number in front of the variable that has a subtraction sign. Notice right here and right here, these first two examples. So what I'm going to do here is I'm going to have to be extra careful with my signs. Remember, subtraction is like adding the opposite. I'm going to get rid of the 12 first, but the 12 is not being subtracted. It's a positive 12. It's like it was being added. Remember, plus signs are like positives, subtraction signs are like negatives. I'm going to get rid of the 12 first. I'm going to subtract 12 from both sides. Or you can think of it as adding a negative 12. These will cancel. The minus sign goes with the 4. It's like a negative 4. So that's negative 4x and that's a negative 24. These do not cancel, they're both negative. So think of this minus 12 as a negative 12 that you're adding. So now it's an easier problem because the negative 4 is times the x, I can divide both sides by negative 4 and I can handle this. And they cancel out as a factor of 1. Negative divided by negative is positive, positive 6. Part B is very, very similar. I have this x here that's being multiplied by a 2 with a minus sign in front of it, so that's like a negative 2x. I get rid of the 5 first. To get rid of a positive 5, I'm going to subtract 5. I'm going to subtract 5 from both sides. I get the minus 2x, which is negative 2x, and I have, it looks like 12. Now it's a lot like the last problem. I have one more step to do, and it's going to be division. My variable is being multiplied by negative 2. I'm going to divide by negative 2. Now notice here that when I write this out, I don't just attach it to this. I write it as a separate step. It's a good habit to get into. So that's 1x, or x, and positive divided by negative is negative. 12 divided by 2 is 6. My answer is x equals negative 6. Now this one is a little bit more like the problems that I did before. There's not a subtraction sign in front of the variable or anything weird, but I am going to still undo with 2 steps here. First I'm going to get rid of the minus 8, and then I'm going to get rid of the 2 that's dividing into. So to get rid of the minus 8, I'm going to add 8. I'm going to do it the more traditional way. I'm going to put it on the ends like that. 12 and 8 is 20. These are going to cancel as 0, and I have r over 2. Now since I'm dividing by 2 into my variable, to undo that, I reverse this. I take the inverse of this, and I multiply by 2. So 2 times the left side and 2 times the right side. This is going to give me 40, and I get r is equal to 40, or 40 is equal to r. And that's my answer. Now I'm going to get really fancy. I'm going to take a story problem here. I'm going to write a 2-step equation by modeling this problem with an equation. And I have to be very careful reading the words and using a little common sense here. Tim makes a down payment of $1,100 on a motorcycle costing $2,300. If no interest is charged, how many monthly payments of $200 must he make until he's finished paying for the motorcycle? I'm going to let x be the number of monthly payments. I read it carefully. Now, payments. Now I'm going to state my variable. In this case, x is my variable. It represents the number of monthly payments. Okay, so now every monthly payment, it's going to cost him $200. So if he makes x monthly payments, that's 200x that he's going to have to pay. Now remember, he put an $1,100 down payment on that, so that's added on to the $1,100 that he put on the motorcycle originally, and this is going to total the cost of the motorcycle, or $2,300. And I have a 2-step equation. I'm going to solve it just like I've been doing from the other problems. The numbers are a little bit bigger, but don't let that intimidate you. I'm going to get rid of the plus 1,100 by subtracting 1,100 from both sides. I get 200x is equal to, that looks like 1,200. You can do this in your head. I'm going to divide both sides by 200. That's times dx. And I get x is equal to, looks like 6. So it will take Tim 6 months. And I formally stated my answer. And that seems logical. 6 months at $200 a toss, that's $1,200. Adding it on to the $1,100 for the down payment, that makes sense. It's in the ballpark. If I'd gotten 60 months because of maybe making a silly arithmetic error there, then I would have looked at that and thought, oh no, that's way too much money. So you have to use a little common sense on this. Now these problems can be solved, these 2-step equations. They take a little bit longer, but mostly if you stick with it and you practice, you'll be good at this before you know it.